second problem then. Second problem, what is the situation in the second problem? So we have, we essentially have this n by n canvas and a k by k grid, or k by k stamp. N by n canvas, k by k stamp. So our canvas is going to be some square grid, and at the end we want certain cells to be painted or stamped, and we use asterisks in the input. So we have a certain cells that we would like to be stamped by the end of this process. And then the stamp is also similar, except the stamp is not of size n, it is of size k, where k can be less than or equal to n. And so our stamp might be maybe, let's say it's a 2x2 size stamp, and it stamps these particular places. And now what we can do is we initially have empty canvas, and we can take this stamp and we can place it on top of somewhere on our canvas, and we can stamp that part. So if we place it on top of here, then it will paint this cell, and this cell, because that is the shape of our stamp. Now I'm also allowed to rotate this stamp. So I can also rotate it so that it looks like, I can rotate this stamp so it looks like this. And then plant it on top of, say, here. So that I'll stamp here, here, and here. And then finally, I can also put a stamp on top of here. I can also stamp here and cover these. As you can notice that we're allowed to cover the same spot more than once. It's just that for the blank spots, we need to make sure we never cover them, because we want to make sure they're blank by the end of this. And so the question is, if I can rotate my stamp and paint a bunch of squares on this canvas, then am I able to create the final canvas pattern with the stamp? It's a yes or no question. And balance, because balance is pretty important. N is less than or equal to 20. So with n less than or equal to 20, we actually have quite a lot of leeway with our solution. So we can look for something maybe pretty simple, or just try to brute force or try a bunch of possibilities. So the key observation is that if we are able to stamp a spot, let's say we are this cell here, right? If this alignment here, we stamp this 2x2 area. If we are able to do that, it doesn't conflict. We don't stamp any cells that aren't supposed to be stamped. We only stamp cells that are painted in the final configuration. If we are allowed to do that, then there's no reason not to. We might as well. From a greedy perspective, we might as well stamp everywhere that we are allowed to stamp, because that just increases the chance that we get closer to the final pattern. And so what do I mean by that? Let's say I take this situation here, right? Then let's go back to this cell. So if I look at this 2x2, this I cannot stamp using this pattern, because that would paint these two empty cells which we don't want to be painted. Here, it would paint only painted cells. So yeah, we might as well go ahead and stamp. Let's do that. I'm going to actually make this example a little more complicated so that we get some more examples of places where we can stamp. So here, if we have this pattern, we're considering it, then we should not stamp here, right? Similarly, we should not stamp here. We should stamp here, or we might not have to, but we might as well stamp here, because all the cells that it covers are painted cells. So just go ahead and stamp that. We shouldn't stamp here. Fast forward, we might as well stamp here because we can. So that's kind of the idea, is we take this pattern and we just stamp everywhere that we can possibly stamp. And then we'll rotate it so it looks like this, and we'll do the same logic again. With this rotated version, let's stamp every single place possible. And then similarly here, let's also do that for this rotation. And with the final rotation, let's also do it for that. So basically, for all 4 rotations, we iterate through the entire grid canvas, and on every single possible alignment of the k by k stamp, and we just check. We can naively brute force over the stamp window and check in every single place where a stamp is, in every single place in the stamp pattern, is the corresponding cell painted or covered in the final canvas. And if all of them are, then we will stamp that spot. And then at the end, after we do all possible stamps, we just go through one more time and see if the final like stampage or the final like pattern that we created matches the pattern in the canvas. And so what is the complexity of the solution? We iterate over every single possible alignment for each of them. So there will be a ×4 factor, but it's time complexity. So we won't analyze ×4. So we iterate over every single alignment. So there are n minus k possible alignments, n minus k plus 1 technically, but it's time complexity. So actually I'll simplify just to n squared to keep it simple. So n minus k squared or n squared. And for each alignment, it takes k squared time to iterate over every single cell inside the window. So it's n squared k squared. And this is fast enough because the bounds are quite small for this problem. Any questions on the second problem? All right. Let's move on to our third